Okay. Anything you see that you're kind of concerned about in the way you wrote it versus how I wrote it? There should be. Okay. Okay. Well, on these, let's just talk about what's acceptable deviation, what's not. 20 set builder notation needs to look like this. It's just a scan of the graph and what x's you use and what y's you use. And then so these right here, actually, you don't have a lot of acceptable deviation. That's what your answer needs to look like. Okay? Sometimes things can be a little different, but this one, when you're describing what to include, well, that's basically what your answer needs to look like. I am going to talk about number 20 real fast because I've kind of hit upon something that seems to be working with some people that nothing else was working with before. Like say 20, if I'm trying to describe the domain and range on 20, we can just kind of scan it. Okay? So if I'm looking for x's to observe what kind of x's were used in this drawing, I can look over here. No x's were used here so far. First x that was used was right here. And it was used all the way over to here. So then as you do a quick scan, you can see that from -3 to 0 was used. -3 is less than x is less than 0. Or equals. Okay? And then if we keep going, oh, no x's were used here, but the x's were used from 2 to 4. Okay? So there's really, that's just scan it. I hit an x, list all those x's. I hit another x, let's list all those x's. Same thing with my y's. Nothing. Ooh, -2 to -1. Got it. Nothing. From 1 to 2. So don't make those domain and range too difficult. Just kind of scan through and see what x's are used and what y's are used. I bet you guys have questions on 4 and 5. Did you write yours like I did? Did you just go 1, 2, 3, or did you go 1 through 6?
No. So, like, for the main, I put, like, 1, 2, 3, 4, 5. I put from...
And that's what I really want. I want 1, 2, 3, 4, 5, 6. And there's a reason why. Okay? Because with all this stuff, we're communicating what information do we have. The information we have here is week 1. Not week 1.5, not week 1.9, just week 1. Week 2, week 3, week 4, week 5, week 6. It's not everything in between. It's just 1, 2, 3, 4, 5, 6. These are specific data points. Okay? Pairs sold. If I said 8 through 44, we sold anywhere from 8 to 44 pairs. That might indicate that I sold 30 one week. Did I? No. Did I sell 20 one week? No. So it's good to list just the numbers themselves. If I were you and this was my first experience, I might have said, yeah, anywhere from 8 to 44. But I want you to see the value of listing them independently. This is what's called a discrete graph or discrete set of data. Discrete means a limited, finite amount. We're going to talk about that today. Okay, any of these you want to talk about before we go into some more terms today? Okay, before I'm going to go any further, I'm going to say, have some patience. This section is really vocabulary heavy. It's really abstract concept heavy. Okay? When you guys thought of Algebra 2, you might have been thinking stuff like this. Solving equations, maybe graphing some things. Hey, getting back to, things that you did in Algebra 1 type stuff. Okay? Where, if you just have some patience, we will get back to what you guys think Algebra 2 might look like For right now, there's just some terminology we got to get through. So bear with us, and we'll get her done. Okay. So today's pretty note heavy. I've just got 5 terms that I've got to go over. So let's get going. If anything in the hall, if that noise ever bothers you, feel free to close that. I don't really have to have it open or closed. It doesn't really matter to me. Okay. First thing we got to do. Oh, this is a long period, isn't it? That's right. Thank goodness. So, first thing, we're still in section 1.1. I want to define a function. The book never defines a function. They just use this word function, 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 function. So we need to define this. Okay? And I'm going to try and keep the descriptions using words that are fairly basic. But basically a function means each input or x has only one result. Each x has only one result. I cannot have an x with 2 different results. Okay? Perfect example. If I take this book, put it on a scale, how many different weights should I get? 1. If the scale's functioning properly. Okay? If I put a different number of books on, yeah, it's going to change. That's okay. But function, each input yields just one result. You'll notice that, well, actually, let me show you something that is not a function. We're gonna do several different visual ways to look at this. So this one is not a function. We'll just do a mapping diagram. 1, 2, 3, 4, 5. Okay. If I plug in 1, I get out 3. If I plug in 2, I get out 4. If I plug in 2, I get out 5. It's not a function. Why is that not a function? Yeah, 2 has more than one result. That would be like you on number 2 on your assignment getting 4 for a result. Your friend getting on the same number 2, 5 for a result. Newsflash, one of you is wrong. Okay? You can't get different answers. And that's one of the things that's great about mathematics is that there's usually just one and only one answer. I got 2 people gone. Help me out here. Chase and Ethan's in here. Okay, so let's see here. 1, 2, 3, 4. So I got 15. I'm missing 2. Okay. Yeah, I'm going. Cammie, Ethan, Austin, Chantel, Chase is gone, Ellie, Camilla, I'm sorry, Holly, Jenna, Caitlin, Zach, Molly, Kim, Owen, Jennifer. Got it. Okay. So we got that taken care of. What would the graph of this look like? This is the important part. This is just to underline the concept But what would the graph of this look like? I get 1, 3, and I'd get 2, and I'd have a point at 4 and a point at 5. Can't be up and down. Because here's the deal. No, it is. Okay? Those two right there, that's the part that violates it. That shows us it's not a function. Because I plug in 2 and I'm getting out 2 different answers. So what's the word you would use to describe those in relationship to each other? Starts with a V. Vertical. They're vertical. They have a vertical orientation there. So that right there shows us it's not a function. So then we come up with this test. It's called the vertical line test. Vertical line test is really very basic. It just says if a vertical line, I'm just going to use some abbreviations here, hits more than 1 point, it's not a function. Okay. Yep. Vertical line hits more than 1 point, and it's not a function. Okay. So then what that's going to allow us to do is not just look at it in this unconventional method, but we can also look at stuff like this. Is that a function? Here's some yeses and nos. We got to think about the definition here. Each input, each x yields one and only one unique result. -5, boom. 4, boom, boom. Each x, I'm only getting one result. Is it a function?
Yes.
Yes, it is a function. It passes the vertical line test. Each vertical line that we could pass through it only hits at 1 point. So then we know it's a function. Okay? So I did something like this. Is that a function? No. Vertical line test obviously shows us that it hits more than 1 point, but why does that mean it's not a function? Because I've got the same value of x, because it's on a vertical line, and it's going to hit 3 different points. It hits way up here. It might get like 6. Here it might be 3. Here it might be -3. I'm getting multiple different answers for the same value of x. Not a function. Okay? Vertical line test. Function. Vertical line test. Function. It's weird how when you talk all day, your mouth kind of gets a little dry. It's weird. It's weird that way. Okay. So, 1-to-1. Okay. This gets a little bit more funky. Okay. So this means that each result only happens once. Okay? Each result only happens once. So, something that would not be 1-to-1 is I had 1, 2, 3, 4, 5. 1, I plug in 4. 2, I plug in 4. 3, I plug in 5. Or, I'm sorry, 3, 1, I get 4. 2, I get 4. And 3, I get 5. That's not 1-to-1. Because 4 is happening a couple different times. Okay? I can only get each answer once. And that answer occurs twice. But let me ask you this, based upon our previous definition, is that a function? Don't worry about horizontal and vertical, just let's think about the definition. Each input only has one result. How many different answers did I get when I plugged in 1? 1. How many different answers did I get when I plugged in 2? 1. How many different answers did I get when I plugged in 3? 1. It's a function. It just so happens it's not a one-to-one function. Okay? So what is this going to look like on a graph? Well, 1, 4, 2, 4, 3, 5, the part that violates it being one-to-one is this part right here. Gee, can you think of a different test instead of vertical? Horizontal line test. Horizontal line test says that if a horizontal line hits it at more than one point, well, then we must have the same thing happening, or the same result happening multiple times, and it's not going to be one-to-one. So HLT, I'm going to abbreviate even more, okay? If any, I need to put an if there, horizontal line hits more than 1 point, then it's not one-to-one. Okay? So let's go back up to these two that I have right here that are conveniently written in this same little quadrant here. The first graph, is this one-to-one? No, because look at the same answers happen all over the place. Answer 1 happens there, it happens there, it happens there, it happens there. The one answer is happening all over the place. Okay? The next one's not even a function, but it's not one-to-one because it fails the horizontal line test as well. Okay? What if I was looking at well, is it going to be a function? Yes, because it's 3 books. It's going to have a certain weight. Is it going to be one-to-one? Yeah. Will each weight happen only once? Well, I have many weights, but say, will 10 pounds happen twice? No. Will 20 pounds happen twice? No. There's a magic combination to get me to 10 pounds. There's a magic combination that will get me to 20 pounds. So is it one-to-one? Yes, it is. I don't remember whose is whose. We'll have to get that straight. I'll punch this out. No, sorry if I messed it up. Okay. Okay. On to. Okay. On to basically means each result happens at least once. Each result happens at least once. Okay? So, we can take a look back from this yesterday to review a couple things. Is that a function? Yes. It wouldn't make sense to say when I was 26 I weighed both 200 pounds and 400 pounds. Okay? It would not just make sense. It wouldn't be good. Okay? This one is at 1 to 1. One to one would mean that I weighed 210 at only one period of time in my life. It's not 1 to 1. It's not 1 to 1. 1 to 1 means one result for only one input. Functions, each input can only have one result. So rely on this if you need to. You know, the comparison here. This value of x can't happen 2 different times. Okay? Okay, so now, onto basically would mean that each result happens at least once. So far as this onto, at any point in time, was I 300 pounds? No. Was I ever 100 pounds? No. So is this one onto? No. So if I would do it, you don't have to draw this little goofy mapping diagram, but if I did 1, 2, 3, 1, 2, or no, 4, 5, 6, 7. Sorry, it's so sloppy. Is that onto? No, the result of 7 never happens. Seven's all by his lonesome. That one is not onto. This reminds me of my group of friends hanging out when I was in high school. Ross had a girlfriend. Tom had a girlfriend. Wayne had a girlfriend, but I was all by myself. It is. It is. That's true. Okay? Some of the best times I've had have been by myself. So now, what about graphing-wise? Is that onto? Give me a result that never occurs. Yeah. So like up here at 8. Never happens. There's no results. There's no X's that yield all the results possible. This one here. Is that onto? Yeah. Every result happens. Well, first of all, let's review everything. Is this a function? Vertical line test. Pass the vertical line test because every X yields only one result. Is it 1 to 1? Yes, because each result only happens once. Okay? It's not, it is onto because everything happens. Everything happens at some point in time. Those are the 3 tough things from today. The next 2 are easy. Okay? So, yeah. No, because the answer nothing ever gets up to 8. 8 is up there by himself, all lonely. Nobody ever comes to see me. Yeah, or, here's another way to put it. What's the domain of any function that is onto? Or, I'm sorry, what's the range? All real numbers. Because everything happens. Discrete. And I know, I'm sorry. I wonder if this is still recording. I hope it is. Yes, it is. Discrete and continuous. Continuous. I'm trying to write a little bit better. I'm trying to also give you guys maximum homework time, right, a little quicker. Okay, discrete. It's kind of a stretch of the English language, but if I say do something discreetly, you just need to do okay, not all the time, just do it this once. Okay? If I look at a graph like this, how many points are on this graph? There's an infinite number of points on this graph. They're all over the place. They're all over the place. They're all over the place. Okay? So discrete means only a set number of points. Okay? So it's a finite number of points, and finite means limited. Or, bottom line, basic definition is your graph is dots. Okay? You have certain points, and that's it. No betweenness, just those points. 4 and 5, like if we're on your assignment today, those would have been discrete. Because there's just certain data points, and that's it. Continuous basically means it's going to be made up of lines, curves, but the big thing is the whole graph can be drawn without lifting your pencil. Okay? No choppiness, no breaks, no nothing funky. Okay? So if I would go like this, is that continuous? Yeah, it's nice and smooth and continuous. It just continues. I don't care which direction it goes, it just continues. Okay? If I did something like this, is that continuous? No. Is this one continuous? No. And you know what? It's not discrete either, because it's got a section that has infinitely many points on it. Let's do a real fast review. I'll wait till people are done writing. Okay, function. Each one of these, is it a function or not? First one, is it a function? Is this one a function? Vertical line test. Vertical line test. If it's, let's say if these two are above each other, it's a function because I used this point and that was an open circle. So this is a function. If I did this, that would make it not a function. This one here, function or not a function? No, not a function. I know, it can't be vertical. At first with the open circle, okay? Let's go back, 1 to 1. Is this 1 to 1? So this is where, okay, you got to slow down, you got to think about the definition. Function, does each input yield a unique result? Unique, 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 unique. No, that's not unique. Okay? Now, if I would go to 1 to 1, that means each result happens once. Each result, ooh, that happens several times. What about this one? Is this 1 to 1? No, because this result happens a couple times. Is this 1 to 1? No, because that result happens a couple different times. Okay? On to Yes, because all the results, positive or negative, they happen. Is this one on too? Yes. Is this one on too? No. Okay. So look back at your definitions. And I think that, definitions are an important part of it. Don't just rely on your tests. Understand what's going on. Okay. So where did I put that? And gosh dang it. Okay, let's get you started. I got a couple problems I'm going to add because I can't find my notes. Page 9. I must not have wrote that on there. Huh. I'll have to find those others because I had 3 others. Gosh dang it. Still working on 29, 31, 34. Okay. And how do I get this thing to stop recording now? There we go. Yeah.